All right, today is 6.2 day 2 lesson, and in this lesson we are going to continue the goals, which is to multiply and divide radical expressions look like these problems. Last one we just mostly worked on simplifying, but it'll be needed when we multiply and divide. So in this lesson we'll start to actually get into some of the multiplying and dividing, which really isn't too hard. It's more the simplify that's the tricky part. All right, so the first thing is two radicals can be combined or pulled apart as long as they have the same index. So all that means here is these are both indexes of n. So if they're multiplied together, we can make a single radical index n and multiply the a and b parts. All right, and so far we've mostly been pulling them apart. So like root 75, we broke apart into the perfect square 25 times the unperfect part of 3. So that square root of 25 becomes 5. Okay, so you can pull them apart like that. You can also smash them together, right? As long as the indexes are the same, you can smash them together, and sometimes that's useful, right? Like radical 8 times radical 2, that can become radical 16. And that's super useful because that's the perfect square that comes out as 4. So the point is you can break them apart, smush them together, just make sure that the indexes match when you're smushing them together. Okay, so in homework there'll be a few that can't be combined. See if you can figure out why we can't combine these two radicals. Okay, and the answer is the indexes don't match. So indexes do not match. Okay, and so just write something like cannot be simplified or something in homework, or combined, however you want to write it. All right, here's a couple examples for you to try then, using like basically we're multiplying, so we're smashing them together and then simplify from there. All right, so letter B, hopefully you had a chance to try it already, becomes a single third root and negative 4 times positive 2. And then remember that you can have a negative radicand if it's an odd index. So this one actually comes out to equal negative 2. 8's a perfect cube, and negative 2 times negative 2 times negative 2 gives us negative 8. So the cube root of negative 8 is negative 2. Next one, the indexes. Remember, this is a visible 2 if it's not written there. So this one cannot be simplified. Okay, and that again comes from these indexes don't match. All right, so we're going to get back to ones that are more like yesterday. So yesterday we were breaking them apart by simplifying. Today on a multiply question, you're just going to smash them together first and then simplify like we did yesterday. So I'm going to make this into one giant square root, and I'm going to combine what's underneath here. So 72 times 10 is 720. All right, and then x cubed and x to the first is x to the fourth. Y squared and y cubed, add those together, y to the fifth. Okay, and now we're going to do it like we did yesterday, which is we're going to break it into the perfect part and the non-perfect part. All right, and so 720 isn't a perfect square, so I got to find one that works. Right, so I'm going to start high on my list too. So I'm going to take 720 and divide it by 144 is 12 squared. And that actually works, so we're kind of in luck. So we hit it right away. So we're going to split to 144 and 5. And put 144 in the perfect part, 5 here. And then I'm going to write it, even though it's not there, I'm going to write the index of 2 there. And this fourth power is already divisible by 2. So I'm going to put all my x's here and none in the back. For y, 5 isn't divisible by 2. So in the last lesson, we talked about y to the fifth can break to y to the fourth times y first, y cubed times y squared times y cubed, y to the first times y to the fourth. But we want the highest possible here that is divisible by 2. So if I go down, the very first one down works. So that's what I want to use. I want to put 4y's here. So now it's divisible by 2. And then we have 1 in my leftover pile. All right, so now the perfect stuff we can clean up. The square root of 144 is 12. And then x to the fourth becomes x squared. Y to the fourth becomes y squared. Divide, right? Dividing by that index. And then the leftover part, the people that didn't get picked for the dance, they're just back here and they just stay that way, the unperfect part. Okay, so sometimes I call this the accordion method because we start with two radicals, smash them together, and then pull it back apart, break it apart into two different radicals, simplify from there. Okay, so it's like an accordion, and I'm worried that kids don't know what an accordion is, so I looked up this kind of sweet accordion video here. So if you've never seen an accordion, this is what it looks like. I like this video because these guys are really rocking the accordion fun, and Keith are really, I'm not sure if it's a lot here, but I love the accordion. Here comes the rock part. All right, so that's an accordion in case you've never seen one before. Oh, this is what I think of when I think of YouTube sometimes too. That's a pretty funny meme. I like YouTube. It's pretty good. All right, so let's get in back and do another question here. Maybe I want to do one that's not quite as hard first. Sorry about that. Let's try this one first here, and you can either try it if you feel confident, or if you just want to watch the video, you can do that too. Goal is to simplify. Okay, so they're both fourth roots, so I'm going to smash them together. And 7 times 32 is, let's see, that'd be 210 plus 14, so I think it's 224. And x to the 6th, x squared is x to the 8th. All right, so now I want to break it apart to perfect fourth power and non-perfect. And so I've got to find, for 244, I've got to find a perfect fourth power that divides this. So normally, again, I have this chart on the board, but my x to the fourth powers were, let's see, I think there's 16, I'm gonna have to look these back up, 16, 81, and then I think what's 4 is, put up the 256, I think, and then 5 is like 625. So there's less choices here. So basically it's going to be either 81 or 16. So I can go to my calculator, try 224 divided by 81. That didn't work. 224 divided by 16. And that does work. So I can make it 16 and 14. So I'm going to put 16 in my perfect fourth power and 14 in the back. And then x to the 8th is already divisible by 4. So I'm not going to split it, actually. I'm just going to leave it there. And now I just clean up. So my fourth root of 16 is 2. And then this divides out now, so it's x squared. And we have a leftover fourth root of 14. And that's it. That's cleaned up. All right, let's try the crazy one. All right, hopefully we got that one now. Where did it go? Sorry, disorganized a little bit. All right, there it is. There's the crazy one. And what's different here is really you've got a number out front, but I'll give you the first step on that. Basically, those are just regular numbers. So we're going to have a 6 and then a big third root where we smash all our third root stuff together and then smash and pull apart like the accordion. All right, pause it, give it a shot. All right, so we already have the first step. And then underneath the check mark, I do 6 times 9, which is 54. Add the exponents here, so it's x to the 9th. 4 plus 5, and then y is going to be y cubed, y to the first plus y squared times y squared, and you add the exponent, sorry. Okay, now I'm going to have a 6 out front, and I'm going to split into a perfect part and a non-perfect part. All right, so 54, again, I would use my list of cubes. So again, those are like 8, 27, I think 64 is next. And then I forget what happens after that. 125. All right, but the only ones that would really work are 27 and 8. Again, this is my x cubed column in my little chart. And so I think 27 will work, 27 times 2. And then the x and y are actually both already divisible by 3. So that's kind of nice. X to the 9th y cubed. So I have a 6 still, and then the third root of 27 is 3 x to the 9th y cubed, and then a third root of 2 in my leftover part. All right, and then the only final step here is 6 times 3. Those are both regular numbers. Now I can make that into 18 x to the 9th y cubed, and we just have one leftover thing of a third root of 2. Okay, and that is our final answer. Sorry about the weird third root there. My pen kind of gave up. All right, it's about as hard as it gets. Hopefully that helps. Up next, right, so that was multiplying, right? This was a multiplying question. And then the final thing we have to do in this lesson is to start going over division. And then we'll start it today and then finish it up tomorrow. All right, so division is same as multiplication. As long as we have the same index, we can like combine it into one radical. Or if we wanted to, we have one radical, we can split it back into two depending on the situation. Just kind of like multiply, you can go back and forth, pulling it apart and smushing it together as long as the index are the same. So like where this might help is if you want to jot down an example, you might want to write down this little formula and then maybe an example here. So in this particular example, because they're both third roots, we can make it into 48 over 6. And that's really helpful because 48 divided by 6 is 8, I believe. All right, and then the third of 8, that just comes out as 2. So we're able to clean this whole statement up into just 2. Okay, so here's one. If you feel confident, try it. If pause the video and try it. If not, you can walk through this example with me. Okay, so again, we're gonna make it into one big square root. 18 x to the 5th over 2x cubed. Okay, and then we're gonna clean that up, right? So what happens is 18 evenly divides by 2 to get 9. And then x to the 5th and x cubed. This is where you got to know a little bit of exponent rules. But basically, there's x to the 5th, there's x cubed, and then they cancel out. So you can pair them up and cancel, which means we just have an x squared up top. And at this point, our denominator is just 1. So oftentimes, I don't even just write that denominator there. We're just going to leave it as x 9x squared. Right, and then this comes out perfectly. Square root of 9 is 3. And the square root of x squared is just x. Divide those out, so this just cleans up to 3x. All right, slightly different one, but same kind of steps, so pause the video, give it a shot. Okay, so I'm going to start with one giant square root and 50 x to the 6th y over 2x to the 4th y cubed. All right, and so what's a little bit different about this one is we can divide 50 and 2 to get 25 and 1. And then x to the 6th, x to the 4th. Here's x to the 6th. Oh, geez, my pen is broken again. Over x to the 4th. And they cancel, 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 cancel. So you have an x squared up top. And what's different with the y's is you have more y's in the denominator than in the numerator. So you have y to the first and y cubed. And those cancel. So our y squared is in the denominator. So we have a 1 times y squared, which is really just y squared. And from here, you can do the square roots of all of these. So square root of 25 is just 5. Square root of x squared is just x. And the square root of y squared is just y. And the 1 really doesn't do anything. At times 1 doesn't affect the question. So this cleans up nice and pretty to 5x over y. So if you want to label this, that's pretty. Okay, so we'll do some different division ones in the last part of 6.2. But today we just kind of covered multiply and division. And you can smash them together, pull them back apart, as long as the indexes are the same. All right, so hopefully that did it. And again, there's one more lesson which will be a little bit weird, but we'll have one more part of 6.2. All right, thanks for watching.